Good morning, good morning. I'm not by myself from Riverview High in Canada. I'm here with some students and they're actually on their day off. They were here last night until about 8 o'clock at night getting ready for this, and now they're here bright and early in the morning on their day off to give you a presentation. So we'll let it go from here. That's you.
Okay, we are super excited to present DNArt, a project combining biology, physics, computer science, and graphic designing.
So the fourth industrial revolution is going to present problems and wonderful opportunities that we can't even think of. It's true that we can Google how many tons of CO2 are going into the atmosphere, how many people are going hungry every day, how many people are struggling to move around the world to find a better life. But Google is not going to be able to tell us how to solve climate change, how to feed the hungry, and what to do with our human migration issue. Students are going to need to have a diverse set of experiences that they can draw upon to come up with creative solutions to never seen before questions. We're going to need a Renaissance education. And so this art project is a chance for my students to gather from Da Vinci and the Renaissance and look into the future. And so how can we create a transdisciplinary experience for our students? Well, we thought about doing an interactive art piece that would involve coding and some physics and some biology.
The colored links represent a small portion of nucleic base pairs in a sequence of DNA. A motion sensor will detect student movement in a hallway. A microbit will do some math with position and velocity. Look up for DNA alley and move the light switch students. Human will act like a scroll bar to cycle through the DNA light show.
So thanks to Microbit and its software, it made coding easy for anyone. For someone with no coding experience, they were able to hop in right away and drag and drop blocks. If you're someone with more coding experience like myself, you're able to code in the language of your choice, as seen in the photo here. Using Microbit really helped our project, and the possibilities are really endless.
The ultrasonic sensor we use does more than just sense the presence of people, but also gives us distance and velocity using sound waves. The microbit sonar extension allowed us to skip past some of the math and physics around echolocation. These are some of our beginning thoughts on ways we could code the project.
So biology and chemistry and of this human living thing that we have is so amazing. It's the coolest machine out there. And so how can we get some of this mystery and intrigue to a whole variety of students? And so we've been able to study things like mystery of DNA and protein synthesis. And so now we have people who are focusing on coding, now also thinking about DNA. And we have people who are thinking about DNA, thinking about coding and those kinds of things. We also have our physics. We got our LEDs, and so we have to worry about color addition with the different colors. Excuse me. We need to think about position time graphs and velocity time graphs. There's a little bit of calculus thrown in there. And then we have to worry about waves and reflection and echolocation. So we put all of those things together, the coding, the chemistry, and the physics, and we end up with these beautiful LED rings that represent some DNA. And so late last night, we were just here last night working on this. Got a little video to show you. There's the 4 a.m.
Technically, it should never do those reds. I'm not sure why it does. So maybe if you don't see it, it's a good thing. I don't know. There we go. There they are. So that's true. So that means if we did have it in a hallway,
yeah,
if we just kept having people walk by, it would keep.
Is this a DNA sequence or is this the color thing?
That could be.
I think you said you're setting colors so they always look strange.
So once the lights were soldered, it was just a matter of putting them together in the right spots so they were transmitting and sending data properly so they would all light up. It was a bit tedious because you had to test every single ring, but in the end it worked out. Here's our logos. From the top left corner and going clockwise, you see the where we started and then where we kind of ended up, with our logo being the bottom left logo.
While working on the rings, we had to be careful about where we placed our solder and wires because it is so easy to make mistakes. We had to use our fine motor skills to look closely and work out what we were doing. And while it was frustrating when we realized we did something wrong, it was worth it when it worked.
This is just the beginning of our project, and there's stuff we want to improve upon in the future. Some of this includes extending the number of rings and solving some of our power issues as well.
Thank you. This has been fun. Let's keep in touch.
And there we have our quick little lightning round. I think we made it in time, just in time.